Hi, welcome to this video. We're going to solve this question here, which is essentially a limits question, but it requires a little bit of algebra before we get to the point where we can do that. And they kind of give us a clue with part A of how to go about doing part B. So really the hard part of this question is knowing how to do part A, and then part B kind of follows on nicely from there. Notice that you could in theory do part B without solving A because they give you already this result. So you could already try to apply this limit question to that without knowing how to show that this is the same thing as that. So whenever they give you a show that question in a math paper, remember that you can use the result for the first part to answer the ensuing parts B and C and D. And in a way, that's why they give you the show that question, so that you don't miss out on showing other skills just because of the lack of knowing how to show the first skill that they ask you to solve. Okay, so that's the first thing to notice here. Second thing is to look at what they give us and try to spot something that you can recognize. So let's see. If I'm given that over there and I copy it here, over the square root of x squared minus 6x plus 13. Now this root ends on 13, so I'm going to put a line going down there. And then I've got a minus 2. All of that is under the same numerator. And I've got to look at this, and I need to show that it's equal to that over there. But before I even think about that, my task here is to simplify all of this, because here I don't have a fraction at all. I don't have anything underneath. So essentially that gives me the clue that whatever I do with this must end up cancelling. Something on the top must end up cancelling with something on the bottom in such a way that I end up with something that doesn't have a fraction at all. So that's already a clue that I think is useful. Another thing to notice, and perhaps the most important one here, is to notice the general form of this. What does it look like that you've done in maths before? It looks a little bit like these questions where you've got something on top. Let's simplify so that it's just a 3. And then you've got underneath root of 5 plus 4. Something like that. And they ask you to simplify that, and it's a process called rationalizing. It's essentially getting rid of the roots at the bottom, making sure that whatever you end up with doesn't have a root at the bottom. And so if the question was just 2 over root 3, for example, that's easy because you multiply top and bottom by root 3. Hopefully you remember that. And you end up with this. Right? Root 3 times root 3 is just 3. When you have the next level up of difficulty is when you have this plus 4 there. And when that happens, you've got to remember the difference of two squares, which is that if I have x plus y and I multiply it by x minus y, I just get x squared minus y squared, right? And I can go in the other direction too. But what's important here is that when I have a plus and a minus, and these two objects are the same, then this just opens to the first one squared minus the second one squared. In other words, the xy terms disappear because they cancel each other out. That only happens when it's a plus and a minus in the two things that you're multiplying. So we can use that at our advantage, or in our advantage, in the sense, let me just rub this off, in the sense that this here, I can multiply it by its conjugate, it's called. And what we do is we say, well, if I multiply it by its conjugate, what I end up is with this. Right? And if I do it at the bottom, I've got to do it on the top, otherwise I'm changing the thing, and I'm not being asked to change anything, I'm just asked to rewrite it, so I mustn't change it. So I do it to the top and to the bottom. which essentially, this whole thing is 1. So I'm just multiplying what I had before by 1, which doesn't change it. But what it changes is the shape of it. This then becomes difference of two squares, means the first one squared, the root 5 squared. Root 5 times root 5 is just 5. And the second one squared minus the second one squared. 4 times minus 4. So 4 times 4, so that's 16. And on the top I just got 3 times root 5 minus 4, that's okay. Now 5 minus 16, I can simplify it and I can leave the answer in terms of this over a number, and that's it. I've brought up the root that was initially at the bottom, I brought it to the top, and I now don't have any roots at the bottom. That is called rationalizing, and it's exactly what we're going to do here. If that looks rusty or you can remember very well how to do that, I recommend that you look for the part in the textbook that is going into more detail about it, and you can do more exercises from that topic. But essentially that's what we do here. We realize that this has a similar form to that, in the sense that you've got the root of something minus something and then something divided by that. So let's see. What do I need to multiply the bottom by in order to get rid of that ugly square root? Its conjugate. And the conjugate looks like this. Alright, so the bottom right now is that plus 2. So, sorry, minus 2. Right, that's what we have right now. So I multiply it by its conjugate, which is plus 2. And then on the top I have the same thing that I had before, times the same thing that we've just multiplied the bottom by, in order to keep it the same, remember. This looks really ugly, but bear with me. Okay, now the beauty of this is that the bottom is now difference of two squares, so that it becomes a lot simpler than it looks like on there. So I'm going to end up with this thing here squared. What happens when I square that? The square root just disappears. So I end up on the bottom with that. It just disappears, the square root. And then I've got to do minus this squared. And that's it. That's the bottom now. It's become a lot simpler and I've gotten rid of the square root. Admittedly, the top looks a little bit messy still, but it's going to simplify a little bit more later, don't worry. All right. Now, the bottom is already easy to simplify because I've got a 13 and a minus 4 there, so I can just write the bottom again. 13 minus 4 is 9. So in the bottom, I'm going to write it down here. In the bottom, I'm going to have this. Plus 9, right? Because 13 minus 4 is 9. And so this should strike you as, well, actually, before I say that, let's look at what we have on top. I've got x squared minus 6x plus 9. I should have put that into brackets. It's bad of me. I don't put it in brackets. It looks like only the 9 is multiplying by that bracket, but it's actually not true. So all the way from here, hopefully you notice that I made that blunder. That needs to be in brackets, because I'm multiplying all of that was here there before by this new thing, right? So that all needs to be in brackets. Now, already without doing anything much more, you should be able to see that at the bottom I've got x squared minus 6x plus 9, and on the top I've got x squared minus 6x plus 9. So those two are going to disappear, because that's what exactly what I have here at the bottom. This is just this simplified, and I've got the same thing on the top, so that's going to cancel with that, because these two things are multiplying. So that disappears, and I'm left without a fraction, which is kind of what I really wanted. I'm left with no fraction now. and I'm just left with square root of x squared minus 6x plus 13 plus 2. This is all I have so far. Now we go back to the original just to keep it in mind because that's what we're trying to show. And this is what we have there. I'm going to write it here so I can refer to it. X minus 3 squared plus 4 plus 2. That's what we're trying to get to. Whoops, crazy zooming. That's what we're trying to get to. And this kind of looks already a little bit similar because I've got the plus 2 here and the plus 2 there, so that's encouraging. And I'm nearly done, really. All I have to do with this quadratic now is to do the technique called complete the square. Now that's when they taught it to me, that's how they call it, complete the square. Okay, and that is done by taking this thing here and kind of guessing what it can look like if you factorize it and then correcting for it. That's how I do it anyway. So people do it in different ways, but if you look at x squared minus 6x plus 13, don't worry about the constant too much and just try to factorize, try to guess what it would look like for that to be factorized. And that, hopefully you can see that it would look something like x minus 3 squared. Okay, now I'm ignoring the root just for now for maths simplicity's sake. Don't worry about that, we can do that later. Really the thing that they want us to prove has a root also, so we don't need to worry too much about the root. All we need to show is that the inside of this is the same as the inside of that. And actually your x minus 3 squared also is a logical choice for your guess because it's in what we want to prove. But anyway, hopefully even just looking at this, you can see that x minus 3 would make sense. And if we square it and we open it up, we will see that we get x squared minus 3x 2 times, so minus 3x, which will be minus 6x, and then minus 3 squared is plus 9. So now if you look at this, it's the same as that there. The only difference is that instead of plus 9, we want to get a plus 13. So what you do is that you go to your original and you add 4, because I don't want plus 9, I want plus 13. So from here I'm going to get my plus 9, and from this other 4 I'm going to get the total 13. And that's really neat because if you look at this, that's where your plus 4 comes from. So actually this whole thing there is exactly the same thing as this. And we just showed what they asked us to show. So there's 2 techniques here that we used. One of them was called rationalizing, and the other one was called completing the square. Through those 2 things we got to the result in the end. Now that just goes to show that your algebra techniques need to be really fresh so that you can pull them out when you need to. And I wanted to do the second part of the question now, which asks you for the limit. The limit of that. Now the limit of that looks like a nightmare, but it's actually the same thing as you had here. There gave you the clue that to do this first in a way might help, and it actually really does help. So the limit of this is the same as the limit of that, because these 2 things are equivalent. You just showed it. So we're going to take the limit of this, which is what we just showed, and hopefully you'll see that it's really easy. The second part won't be worth very many marks because it's very easy. So now let's look at the limit. So what we're being asked to calculate is the limit as x tends to 3. Okay, it says it up there in the question. Hopefully you can see it here. Actually I've zoomed out so much that we can't read it. X tends to 3. So x tends to 3 of x minus 3 squared plus 4 plus 2. And this is a really easy question because as x tends to 3, all that's going to happen is that this thing is getting closer to 3, therefore this thing is getting closer to 0, therefore this whole thing is going to 0, and it matters less and less and less and less. The more this gets close to 3, the less this thing here matters. In other words, the whole thing tends to, which is root of 4 plus 2, which is, well, this is 2 and that's 2, right? Root of 4 is 2 and that's 2, so this is 4. Okay, now some of you might be thinking, but the square root of 4 can be positive 2 or negative 2, and therefore this could be 0 or 4. And I can't quite answer that for you right now, why we choose only the positive root, but I'm pretty sure in this case, and if you plot the graph, you will see that when x is 3, this thing goes to the coordinate of 4. So that's it. When I'm doing these videos, please feel free to skip ahead, and to if I'm saying something like the rationalization, which you already remember, or the completing the square, if I go off on a little bit of a tangent, just feel free to jump ahead, and also stop the video whenever I give you enough clues. For example, here, if I already mentioned this and you already knew where I was going, by all means stop it there, pause it, try to do it yourself. If you get stuck, then press play again, etc. Okay, be proactive with these videos, because otherwise it's just you sitting in a chair there, and it's not so valuable as revision time. All right, I hope that was useful for you, and I'll see you in the next video.